Yes, it is. So that's I feel like, if you come on something at noon and there's no one there, it's a blank screen, like that would be like, what's going on? And then people are
Right.
chatting, it's all right. So yeah, we've got a handful of people on the YouTube. I sound like I'm now. Yeah. Okay. Cool. So yeah, so I think, do you guys have any questions? You feeling
Feeling
okay?
I
good.
think we're good.
Did
Yep.
you coordinate your outfits?
No.
No, we're just naturally blah. Yeah.
Well, I wore my dad's sweater, literally my dad's sweater here, but I don't have the polo.
Oh, yeah.
Yeah.
I mean, that would be fun though. Maybe sometime we'll have to
We'll have to try to do it. Yeah.
Yep.
It was Christmas. We could have picked green and red, huh? So
There you go. Yeah.
Yeah, I still need to paint the back. This is my new house, and the wall color is kind of blah, and I'm like, this needs to be spiced up. It's gonna be anyway. So I think we've got our crew here waiting. So we won't make you guys wait any longer. Thanks to everybody who's joining in live today, December 13th. At least in Madison, it is blue skies, sunny weather, no snow in sight for a good couple weeks, but we do know it's coming. So yeah, thank you so much. My name is Allison Madison, and I am the program manager at Wisconsin Saltwise. So working to promote best practices in winter maintenance that can, reduce the amount of salt pollution that we're seeing show up in our lakes, streams, and drinking water. And very, very excited today to bring two national, even international, I'd say, experts here in winter maintenance. Wilf Nixon, Mark DeVries. I've had the pleasure of meeting and working with both of them out in Colorado at the Snowplow Rodeo, down in Chicagoland. Just got to work with Wilf last week at the Wisconsin DOT Tech Talk in Fond du Lac. So the two of these guys have combined decades of experience in the world of winter maintenance and education around that. So I'm gonna kind of keep my comments short here and turn it over to the two of them. If you've joined us before for webinars, you know the basic format. If you have any questions for these guys, you can type them into the YouTube chat, and then I will be able to read those and share. If for some reason YouTube chat does not work, you can email me directly at wisaltwise@gmail.com, and I'll put that email into the chat. So you can use that as a way to get your questions, thoughts out there. And then after today, this webinar will be archived on our YouTube channel. So you can come back to it or share it with other folks. So thanks again so much for joining. And with that, Wilf and Mark, I'll turn it over to you guys.
Awesome. Thank you so much, Allison. It's great to be here with you, and looking forward to this. Mark?
Yeah, I'll go ahead and try to share my screen. Thank you so much for having us on today, Allison. This will be fun. We love any chance we get to work with you. It's been our pleasure to work with you on several different occasions, and glad to be part of the group today. I think this will be a fun one for everyone. So let me see if I can share my screen and do it without messing it up. So
we've seen it all before here, so
yeah, let's see if this works. So please let me know if you can see it.
Looks great, Mark. All right, I'm going to mute
Great. All right, Allison. Well, again, thank you for being here. Wilf, you and I will just be interactive today as we go through this.
Absolutely. Yeah.
Well, we've talked on this many different times, but the title today is, on the cutting edge, and I think this will be a fun one for you. We're really going to be talking about some of the latest technologies in winter maintenance. We'll talk a little bit about some of the newer mobile devices that are out there. We're going to be talking a little bit today about dynamic spreading, which is an ongoing research to really go to automated spreading, might be another word, but we call it dynamic. Then we'll also kind of how that data can be used in automated spreading. And then I think we'll talk a little bit about AI today, which Wilf will have the majority of that one for sure. So
right,
we'll just go through these together, and kind of cover them as we go through it. If you have any questions, please, put them in that chat, and Allison will chime in. We don't have to wait to the end, although we hope we have some time at the end for questions specifically, but we'll just see how this goes. So with that, there we go. Okay.
Yeah.
It took a little bit for that to change, Wilf. So we may have a little bit of delay in there. So wanted to start
Okay.
off, and again, we want to talk about some of the latest technologies that are out there in winter maintenance and what people are doing, and share that with you today. So these particular pictures here are from Minnesota DOT, and Minnesota DOT is in the process of developing a snowplow driver assist program. And this technology has actually been around for a little while, used up in Alaska, where they do it a little bit different than this system is being developed, but the idea is the same thing. When you look at the picture on the left, when we get visibilities that are near zero, and we're normally in every winter, we'll find a few situations of extremely high winds, perhaps blizzard conditions when we talk about the Dakotas and northern Minnesota. And it may lead to roads actually having to be closed because of it. And Wilf, you and I have spent some time even out west where, major highways have had to been closed. And
Yes.
with that, that can ultimately shut down operations. Well, with these systems, we shouldn't have to. So Wilf, maybe you can explain a little bit of what they're doing in these systems.
So the idea is you use some sort of sensor input. And when they first started this, they were using embedded sensors in the road. They were using a special tape for the center lines, that sort of thing. Nowadays, they're using highly accurate differential GPS to tell you where the truck is in relationship to the road, and then providing visual information. You can see on the right-hand side those arrows indicating to the driver that maybe they should move over a little bit to the right-hand side. So it's not steering the truck for the driver. It is assisting the driver to steer the truck correctly. And that can be a big safety help, right?
Right. These also have forward-looking radar. So should there be a car stuck in a bank or something like that, they're aware of that as well, so that they don't plow the car off into the ditch. So things like that as well.
Yes.
But yeah, we'll always call them driver assistants. Driver still has full control, but the idea is in virtually zero visibility, they can still go up and down the road plowing.
Yep. Yep.
Good.
And it works, right?
Yeah, it does work. Minnesota had 2 of these last winter. They should have 4 trucks equipped with these this winter. Obviously, one of the things that happens is how expensive is this, versus how often do you use it or do you need it? But I think, again, Wilf, you can touch on the economic loss to any road being closed, yet alone major ones.
Yeah, major roads being closed, you get up into the millions of dollars per hour when they're closed. There's also, the safety for the operator. Knowing where you are on the road can quite literally save your life. And things like that are incredibly valuable. The other thing is trucks these days are costing between $400,000 and $450,000 fully equipped. Yes, there is additional cost to a system like this, but that additional cost is also potentially saving you an additional $450,000 when the truck you equip does not run off the road. So
yeah, exactly, we're doing no one any benefit if we're off the road. So
no.
So kind of down the same line, this came out of the Transportation Research Board meetings that Wilf and I are part of. And they are now using autonomous snow blowers on the expressways in Japan. Again, I believe this is just a pilot program, Wilf, but we're starting to see more and more of autonomous, and I think you're going to talk a little bit about that when we get to AI, how we can utilize that stuff in winter maintenance. And in this case, these units are off the road. These aren't on the roads, but they're doing shoulders and moving snow back when there's enough of a situation where they're needed. And the idea again being you can have the snow blower running and the operators virtually doing nothing. And I know this picture shows somebody that's in there, but I think it's actually running itself, if I'm correct.
Yes, they because it was an experimental program, they were required by Japanese law, as I understood it, to have a driver in there, even though they were actually not doing anything. And this actually is a very sane and sensible way to start getting good knowledge about autonomous equipment operation. When you are cleaning up the side of the road, you're not really, or you hope you're not, interacting with traffic. So you can gather a lot of information about how these things work, about what the issues are, without putting anyone at risk, the traveling public or the operators. So it's cool. It's a neat system, and it looks like it's really working for them, right, Mark?
Yep. Again, just something we wanted to share with you. I don't know of anyone in the U.S. doing it yet, but once it's been piloted there, you can imagine it's going to start working itself all around the globe. So.
Yep.
Yeah. How about this one? Could we use electric vehicles? So the one on the right that you see here in this picture is actually over in Scotland. They call it a fully electric vehicle. I don't know to the extent is that just the spreader and the plow itself, but fully electric vehicle. And then the one on the left is obviously not a snowplow, but the testing of can we make trucks electric and make them useful? So Wilf, you and I have discussed both of these before that, we can't just park the truck to charge them, right? Or we have to have a way of charging them very quickly. But
right.
This is certainly an area that we're looking at more and more in our industry.
Absolutely. And it was interesting at the APWA PWX meeting this August down in San Diego. There was a lot of electrically powered equipment on the show floor, excavators, smaller bobcats, all sorts of things. I think my sense of things, and I've put stuff in the APWA reporter on this, is from the point of view of winter maintenance, electric vehicles are not ready for prime time yet. We don't have enough charging capacity on the trucks. We don't have the range, and they take too long to recharge. You would basically have to at least double the number of vehicles in your fleet to get the same performance as you currently do out of diesel-powered trucks. But that's today. Who knows? That it's clearly there's a lot coming in this regard, and none of us says anything about other alternative fuels, like, for example, hydrogen fuel cells, which I think this is still very experimental, but I'm expecting to see more of that coming through in the future. Have you seen any of the agencies you've worked with, Mark, using electrical stuff, if you will, for real?
We again, there's certain applications right now, I think, in public works that you could push those towards, but not in the plowing, not in that end yet. Now, you and I are a little bit skeptical of could we actually make these work, but I was amazed when I heard about this truck going 365 miles, and then they, that's one thing to be empty, but then they put a full load of drill pipe on it, and it still went 235 miles on one charge. Again, that's a start. we'll see where they go down the road. But it's something, obviously they'd be better for the environment in certain areas, but electricity still has its own issues of how are we actually producing that in order to charge these vehicles. So there's always trade-offs and everything, but we wanted to make you aware this is on the horizon. There's things being done in this field right now.
Very much so, yeah.
So I put this in here. It's more of a safety thing, but I thought Allison might be interested in this too. That Wisconsin actually, now has green lights in Wisconsin. It kind of started over in Michigan and Ohio. And the thing that's interesting about these is that in order to use green lights, it takes you going and getting legislation passed. And Allison could probably tell you firsthand how hard it is to get legislation passed.
Yes.
So, but they are now being used in Wisconsin, which is a fantastic thing. As you see up above, it says that they're the most visible that there is during snowstorms. Most agencies are tying these in with amber lights simply because during the day, they're not quite as visible as they are when it's bad. So a lot of agencies have had amber lights along with green lights on their plows that have implemented these. But the other thing is it kind of makes municipalities, snow plowing and everything a little more unique than every construction truck that's out there and everybody plowing driveways. The green in this legislation generally has been focused on for municipal use. So
Yeah.
I don't know if that'll hold up long term, but it is good. So
Allison, do you have a comment on the legislative process?
Yeah, I'm going to say like no comment on that right now, but but I mean, we are the green and gold state here, so it's only fitting, right? That we
there you go.
And I know Nate up in Green Bay, yeah, it's all about it. They jumped on that one right away.
Absolutely, and it is much more visible. It's it's a really cool thing.
Yeah.
And it's interesting state to state that this is different because in certain states you can't use blue, in other states you can't use red, and other states they are allowed to use those colors. So it's interesting that this is state to state. So it doesn't mean it's coming to your state soon. It's really more about what the in-state rules are. And then from there, if you are allowed to do it, did you need to actually get legislation passed in order to do it?
Right.
Okay. This one I threw in there a little bit, not that multimodal is new, but our priorities are changing all the time on multimodal. And the question I put here is, do we need to treat them? It's one thing for a person to be out walking, but then we're talking about bikes and bike lanes that have to be maintained throughout the entire winter. The priorities on these have gotten higher and higher. And then I added these cool little electric scooters, which for whatever reason, some cities decide they don't need to put away come winter. So then what kind of level of service is needed for them as well? In an area where we're doing everything we can to minimize the amount of materials we use, we're being pushed for multimodal, whether it's bike lanes or paths or walking paths or motorized paths to actually give a level of service that's much higher than we ever used to have to do. So I just thought I'd kind of throw it in and add anything you want there, Wilf.
No, I think this is a growing issue. I was seeing an article today about some northeastern cities that are now requiring bike lanes to be designated on every street going forward, and special methods of taking care of them will be needed. That's the way things are going. Like you, I'm not so sure about the wisdom of using those little scooters in the wintertime. But if they are there, people will use them.
Yeah. And
yeah. Go ahead.
I'm going to actually share for just a second here. Snowy-Wan Kenobi here. Did this come up? Is a bike path clearing machine that's owned by the city of Madison's engineering department, because it's separate than streets. It's actually engineering that has to maintain the bike paths. So this is on the Southwest Commuter Trail. So it was one of the named plows last year. I'll end that share, but I do know, I mean, in the city of Madison, and I mean, that's part of why I live here. Like a lot of people bike commute year round. So when I lived here for grad school, I didn't even have a car. My bike was my transportation. So, it makes sense kind of maintaining that. I know a lot of people will put studded tires on, or, the prevalence of the fat tire bikes has grown quite a bit. But it does keep more people off the roads. But then, yeah, that pressure, and also, as a cyclist, you don't necessarily want to be seeing a ton of salt, right? Because the damage that does to your bike. So,
Yep.
Yeah,
Exactly.
it's being pinched in both ways, right?
Yeah, and I'm sure in your teachings you're doing the same thing, but trying to understand, can we treat that, and can we do something like liquids only, where perhaps we're using less material or alternative chemicals that go with that minimize the impact that we've got to make. But it's something that agencies have really struggled with. We have to buy equipment we've never had before. We've got to consider, do we actually have to treat these? And it's just adding to the overall program, and what priority do we have to give them? So
Right.
Just something we thought we'd throw out there, because it's a change for many agencies.
No, great question. And if people joining in want to, put questions or comments about that, or, any other topic, feel free to do that. So
great. Okay.
All right.
I am trying to advance it, Wolf.
It's okay.
And I don't know what happened, but I can't. Oh, there it goes. Sorry.
Okay. There we go.
So next up, something else we want to talk about a little bit, and this is something, as you may know, we just had some storms that went through northern Minnesota, and actually more over into Dakotas the other day. And something that's a tool for agencies to think about and use and really truly help the public is sharing your AVL data. And in many cases, where's my plow, and when will my street be plowed? And those are the type of questions, but it really helps the answer of, should I be using the roads today, right? Should I be using the roads today? So this is something that's become really popular. And if you look at the dates on these, I just loaded these up here in the last day or two. This is what was going on in Minnesota during that event, right? And that event started as a freezing rain event, and actually the winds got incredible. It was not a huge amount of snow, but when you look at images like this, and they're coming right from the guys that are out there, the people that are out clearing the roads, it helps you make a decision of, is this really the right time for me to go out? And these sites now, and these are all basically through their 511 systems, they're available. You simply go there, turn on the plow cams, you can turn on weather stations, you can turn on cameras that are located all across your states. And some cities have adopted this same type of policy now as well. And it really gives you a great visual of how's the storm going? Is it the time right now for me to travel? Should I wait? And even the one in the bottom right corner was the day after. They couldn't get them back to bare pavement with the ice that was on underneath. Today they look great again, but it was a difficult storm. It was a much more difficult storm than you might have thought.
Hey, anytime you've got freezing rain in there, it's not going to be fun, is it?
No, temperatures were just that borderline to start with, and then of course they've dropped now, and today is actually quite cold this morning, but there's a warming trend coming right back again. But again, I think it's something that helps. And Iowa has these, the Dakota has these, Michigan has these. Most of the states that are that have AVL systems are sharing their data now, and in many cases allowing you to actually look out the window of the plow and where they've been. So, kind of a cool thing. If you haven't done this, I recommend you go to any of the state's 511 systems. And if you're a state that is likely to get this weather, it's a great place to go look at what's actually going on and what conditions you might face as it moves in. So
yes. Yep.
So we'll talk a little bit, again, Wisconsin, a little bit more about their liquid only routes. Well, why don't I let you talk about this a little? You know the history here, so does Allison, of what Wisconsin's really been pushing.
Well, on some of their very high level of service roads, instead of using the standard pre-wet salt, they began several years ago to look at using just liquid salt brine throughout the storm, not just as a pre-storm application. And what they have found is on the right roads with appropriate level of service and cycle times, it can be a true, it's a really effective tool. It results in significantly less total salt usage, which is brilliant. And what we're seeing here is one of the things that one of the Wisconsin counties has developed for their liquid only routes. You can see at the back of the truck there is a sort of L-shaped bar with a series of nozzles on it. And that's what they use when they're doing the liquid only routes, to put the liquids down at the crown of the road. And why do they do that? Because then gravity and the flow of the traffic will move that liquid across the road in its most concentrated form. And they found it works to be, for the roads they're using it on, a very effective tool. This is really one of the most interesting developments over the last few years, I would say, in terms of operational strategies. It's not for every road. Let's not, suggest it is. You need short cycle times on this, but on roads where it's suitable, it can be a really effective tool. Allison, I think that's been borne out by several studies now in Wisconsin.
Yeah, definitely. And I just put a link into the chat of Bill Kern's webinar. So he did a webinar with us, I'm sure it was a year ago, 2 years ago at this point. And he kind of goes through the story of how they got to where they're at right now with liquids in Jefferson County, kind of a multi-year pilot program. Do you know, Will? I don't think this isn't a Jefferson County truck, is it? Do you know?
No, I think it's Wood County, isn't it?
I think this is Wood, right?
Okay.
Yeah.
Yep.
Yeah, I need to definitely connect with them because I know they were part of the study with Andy Bill. So I'll also put in, for folks who don't know, Andy Bill is at the UW TOPS lab. It's a traffic lab, and in Madison, they just, I don't know, well, I shouldn't say just now, probably a year ago, right? Like put together a study surveying people across the country and looking at their liquid rates. So we have Andy's webinar also archived, so I can put that in the chat too.
Excellent.
Yeah, and that's a great point. I focused here on Wisconsin because we're doing this for Wisconsin today, but states all across the U.S. now have implemented liquid only stuff, and some of them have been doing it for quite a few years, like Ohio.
Yeah.
So certainly, certainly not Wisconsin alone by any means. And again, this is, it may be even easier to implement it at a county level or a city level, where you've got lower speeds in many cases and more flexibility than at the state level. But Wisconsin State has been pushing this very hard that the counties do this, and offered them some real great help to go along with it. But we're seeing it again all over the country where agencies are doing this.
Yep. And it's working really well.
Yep. So I didn't want to just leave it to the US, right? We'll talk a little bit about what we see overseas as well. Sorry about that. It's kind of been the same thing over there. And when you look at some of the equipment there, it obviously looks much different than what we're looking at here. But the idea is, can we actually get it slushy? And if we can get it slushy, can we remove it in even more unique ways? And in this case, you can kind of see on the picture on the left a vehicle that has multiple rubber blades. They put these on trucks. They also put this on heavy equipment. And this is kind of what it looks like. You've got a grader here that it's not only removing the snow with the front plow, but it has those squeegee blades under it as well. And you've got one over here on the left. And once again, we're looking at heavy uses of liquid, sometimes with some granular as well. removal with rubber blades that really clean almost better than any kind of a metal blade. But again, you're not looking at hard pack here. You're looking at slushy conditions, which is what they're trying to create and remove them that way. So again, it's a little bit different use of liquids than what we kind of see here, where it's liquid only, but it's very unique and it's worked very well for them.
Mark,
Yeah.
where are those trucks or in the grader? Where are those photos from?
Yeah, these are Sweden that I have here, but they're doing this in Sweden and Norway, both areas. Again, these come out of some of the things that we get when we share what we're doing internationally through some of our conferences that we work with on those, and at our Transportation Research Board.
Awesome. Yeah, it definitely, poke some holes in this idea of plow and salt, right? You don't always have to plow and salt. You get it to where you need it to be and you move it off, right?
Yeah,
Exactly.
and Wilf and I saw some unique stuff, including a tow plow using some of this similar stuff when we were over in Poland at International Snow and Ice Conference as well.
Yeah, it's and this is good. We have to look at new ways of doing, if you will, the same old thing. The same old thing is getting to a bare pavement, but now we have new factors influencing how we get there. Specifically, we want to get there using as little salt as possible, and these are ways that work very well in that regard.
Yep. Okay. Something else that's out there now that is very recent, and you'll see different companies here that supply these are IoT sensors, or the Internet of Things. And basically, these are giving you very limited data, but they're really cool because you don't need a big system to do them. The one in the middle you can simply place in the ground in epoxy. The one on the left and right, then attached to poles. They can give you, as I said, limited data. So road temperatures, whether it's wet or dry, or chemical amount for the in-pavement one. And the other ones are giving you things like the surface temperature, the air temperature, dew point, humidity. Very, very useful if you can put them up on a pole, say on a bridge, or near an intersection or a road. The whole idea then being they simply use the internet as long as you've got a good cell signal in the area. You can also add cameras here that are usually solar, so you don't have to have power to these. These are all powered by batteries, and batteries that will last guaranteed 3 years and maybe longer. So a low-cost, good solution to get some sensors in the field to give you data of what's going on your roads. And these can be any type of agency can put these in.
Yeah. And when you say low cost, Mark, these are at least an order of magnitude less expensive than a traditional road weather station, right?
Oh yeah, way under those type of costs. But
yeah.
And generally these are sold not so much individually, but like in bundles. So you put 3 or 4 of these throughout your agency. So Yep. Okay, just something else that's new out there. I threw this one in. It's really coming a long way. So we have cameras throughout our systems all over this country, and they're sitting there looking at our roadways. And this is where a little bit of Wilf's AI comes in here, right?
Right.
As I show this picture, I said, can you imagine the day you get woke up with a phone call or a text message, some sort of an alert in the middle of the night, and it's not your police calling you, and it's not your weather station notifying you, it's your camera notifying you that the road has become a different condition. That
Yep.
sounds amazing, but we're actually there. We're getting to where we have smart cameras.
Yep. It's a cool technology, and it's a couple of things. First of all, the quality of the images is so much better now on the digital cameras than it was even 10 years ago. And secondly, the ability to interpret them using AI is rapidly improving.
Yeah. Yeah, so in this particular case, you can see up there, it gives a description of what it thinks the road is, or what it has determined the road is. And, we've got wheel tracks, an asphalt road, it's overcast, it's slushy, and it, in this case, feels the road is slippery. Now, that's all given just from a camera image. Now,
Mhm.
is the road slippery? The only way you could do that is measure it, right? Or hit your brakes. But again, they've gotten very smart.
Yeah.
Yep.
And I mean, I think the other part of that, Mark, like you said, know that the road is, covered with something. I was up in Duluth this fall, and the county that Duluth, Minnesota is in is the largest county geographically in Minnesota. And they said, prior to installing smart cameras, and I think it's going to escape me now the company that they went with, but they would decide, okay, yeah, we're going to send the crew out, we're going to send people out to plow, or send people out to plow and salt, whatever it might be, but some parts of the county needed it and others didn't, right? So
Sure.
it's
Yep.
a waste, right, of all those hours there, and potentially material too.
Yep.
Exactly. Again, it's an up and coming technology. It's not widely used yet, but it is becoming more widely used. And again, the interpretation, you almost want to have a benchmark and something that it's seeing in order for it to learn, and then from there, you get more and more confidence in what it's returning to you.
Yeah, I think they went with something called the barn owl, which I think it was initially produced as like a game camera.
Sure.
They're working, and a lot, they said they ended up attaching some of them to trees, or telephone poles, things that were already up there.
Yep.
But
Yep,
really cool.
exactly. Cool.
It is.
Okay, so we want to concentrate a little bit on some of the advancements that happened in mobile data and where that's going, which leads us into our dynamic spreading talk. But as we look at the evolution of mobile sensors, we've for many years have had things that we can put on our vehicles that will give us the air temperature and pavement temperature. And then they got a little bit better where we could include something like dew point and humidity, things like that went with them. But that's pretty much what we've had for many years. And in the last few years, that technology has really changed. The weather stations we have alongside the roads have changed as well. In fact, they changed first, where we started using non-invasive sensors that could shoot the pavement using eye-safe lasers and let us know what the condition of that pavement is. Basically, I'm wet, I'm dry, I'm slushy, I'm snowy, I'm icy, whatever that would be, how thick that is, and then actually give us a grip factor, how slippery the pavement is as well. And we turn that around and now have that in mobile sensors, which we can put on vehicles. And initially, again, these were pretty much just supervisor vehicles. But in the last 4 years, there's been developments and testing, and some of the sensors now are plow ready. So that means we can give this information right to the operator that's in the truck. And that has been kind of a game changer with that.
Absolutely.
So
And
you can chime in a little while I move on. So, yep.
I was just going to say, if you really want to break a piece of equipment, put it on a snowplow. It's a very harsh environment. So getting these plow ready is huge.
Yeah. So what the systems generally take in, you've got a sensor on the vehicle that looks like the one on the bottom right here. It's shooting the pavement. It's also it's shooting the pavement with lasers to get the condition, but it's also shooting the pavement to get the temperatures as well. That data in the truck can be shown on a cell phone that's in the truck. That phone is showing the data, and the one there is showing graphs, but we generally show numbers, and I'll show you that. The same data at the same time can be sent back to the agency, so that you can see what those conditions are. Anything that the unit is reading can be displayed at the agency as well, along with a visual of what the road ahead looks like. These are always installed behind the plow. So what it's reading is what's left. That's what you're treating. So how have agencies used these? So there's a picture of what the operator would see. What is the grip level? He can decide whether he wants to see the condition, like it's slushy, the thickness, the air temperature, the dew point, the humidity, whatever he wants to see, he can see in the cab. And he's getting real-time observations. So Will, if you can talk a little bit just how operators have adjusted to this almost immediately when they had this tool on their truck.
What was interesting, and this was with the very first operators using these, they started saying, oh, well, you know what? If the friction is good, whatever they decided good was, I don't need to apply salt, or at least as much salt. I can turn that down. On the other hand, if it's bad, maybe I'm not getting enough down there. So they are using this grip reading to directly influence their application rates, which is awesome.
Yep. And then the next slide kind of talks about what we worked on together, Wilf, and we did this with several other professionals in the industry. Once we started seeing that operators were almost immediately looking at grip and saying, okay, if the grip is falling, I need to add more. If the grip is rising, I need to add less. What kind of a suggestion would you tell me? In other words, there's been treatment suggestions out there for many, many years, but they never included things like grip or kind of what road conditions were. So we used a lot of the existing data that's out there of what they do in 2-hour cycle times and what's normally recommended, but we also took into account temperature trends. In other words, is it 10 in the morning and temperatures are rising, or is it 6 o'clock and things are starting to fall? And we took what generally the most general rules out of those matrices were and combined them with what the friction's likely to be, what the pavement temperature range would be, and kind of came up with this treatment suggestion card.
Yep. And it's nice because it is very much suggestions. Each agency has their own process and guidelines and levels of service. This is just if you will, a starting point for the operators. So it's a great place to begin.
Yep. These cards are available. If anybody would want one, simply just let Allison know and we can make sure that you get those as well if that's something that you would like to look at some point. But it's a cool start to this. But then it went on from there. Excuse me. So the industry, besides looking at how those sensors work and the great information it gives the operator and the agencies have been trying to figure out, can we go out and put down what's needed based on data? And that's where some of these projects have kind of started. All of these right now, I would say, are still in their pilot formats. The ASSIST program in Europe started maybe 8 years ago already, Wilf, with Norway and Sweden.
Yes. Yeah.
And initially what that was to GPS an entire route and spread based on the route. In other words, we can automatically change from 1 lane, 2 lanes to 3 lanes, depending upon where the truck is. If he's going up a hill, we want to put down more. But this was still pretty much a constant rate other than changing it based on lane width or terrain. It wasn't basing it on conditions of the road. So that system is out there. That system is being utilized. It's a good system. There's no doubt about that. I think it needs to take into account more of road conditions and how much we need to be putting down based on conditions. Indiana, what you want to talk about their smart plow and what they've done?
Sure. They take care of Interstate 470 that goes around Indianapolis, very busy road. And for much of their pre-treatment operations, when they're anti-icing before a storm, they will pre-treat their most vulnerable areas, which would be bridge decks, it would be underpasses, anywhere in the shade. And what they were finding was their operators were having to turn the liquids on and off a bunch of times. I mean, literally hundreds of times doing a circuit on 470. So they use GPS to create geofencing, which now automatically controls the application of the liquid. So the operator can just drive. It's a lot safer. It makes sure you don't have situations where, oops, I forgot to flip the switch. And, it is indeed a smart plow.
Yeah, and again, this worked in conjunction with AVL. It worked with the controller. Obviously, it had to work remotely where they can turn it on and off as it goes through these areas. They could even adjust the amount. And I thought one of the cool things that came out of this study, it won't treat a second time if you go over the same area, which is really kind of cool. So that worked out really good. I think that study is still going. It was Purdue University working with the agency, but one of the key players is no longer at Indiana DOT. So I don't know how far it's gotten since he's moved on.
It is still ongoing, and they are actually it's in, if you will, operational use this winter on 470.
Cool.
So that's cool.
Great.
Yeah.
So once again, there's this pilot that's going on too, and this is the same sensor that I showed you in one of the recent pictures. This is mounted on the plow truck. It's giving that. If the operator is adjusting to basically what he was seeing, and as conditions change, he can't constantly sit there and do that. It just doesn't work. It's very general. When they see it drop, they may turn it up. When they notice that it's come up, they may turn it down, but they're not constantly doing that. They can't. But if we can read the data, why can't we spread based on the data that's coming from that unit? That was the question. And so there have been ongoing pilots. It was in operation last year, and we have more people involved in pilots this coming winter that are doing this exact same thing. So based on the friction and perhaps other parameters, but right now mainly based on friction, depending upon what this reads, it will put down given amounts based on the friction, based on what the agency is using and what their normal level of services are for the roads it's going to be on. So the agency decides, based on this friction, I want this much. Based on this other friction, I want this much. So right now, they make the decision because agencies will decide to use different chemicals, different procedures. They can have different types of storm situations. And there are times that you just shouldn't be spreading salt. Perhaps in some of the pictures we saw with blowing snow and things like that, where you want to wait till the wind dies before you spread. So the agency, the operator has to be able to go from a manual to auto mode, things like that. This is going on again this winter. The initial results have been really good, really good. It's amazing when you look at how friction changes, how much it changes throughout an event, how often it's changing. And amazingly, the hydraulics on the new equipment is working well enough. It changes almost immediately as the friction changes. So it as you go over the bridge, you don't miss the bridge. It does the whole bridge as it changes the friction going over that, or going anywhere from slushy to icy. It immediately changes the rates and things. So it's been really cool.
Yep.
So we're excited about where that technology is going to. This is not to take anything away from operators. It's to assist operators, and it needs to be proven that this works. And again, there will be refinements, but the whole goal here is assisting the person in the truck, making it easier for them to do their job, concentrating on the other things that are so important. Again, these were some of the early results of what they did. This was one of the pilots. Just kind of shows you what's going on. You actually see this in the controller. It picked what it would do and change. This was just one of our phase 1 studies. Okay, Wilf, I don't think I can help you a lot here. So tell me when to switch
you never
sides.
know. Yeah. AI, it's obviously it's kind of exploded on the scene earlier this year with the whole ChatGPT and various other large language models. It's a potentially very disruptive technology. One of the things we are looking at is How is it going to impact winter maintenance? And in some ways, it already is. Mark talked about using smart photos, smart cameras. That's a form of artificial vision, which is driven by what we know as artificial intelligence. So too with automated driving, speech recognition, so on and so forth. So let's move forward, Mark, if we could. And while that's what AI does, what it really is a system of computers that thinks and acts like humans, or if you don't think humans are particularly noteworthy in terms of our thinking and acting, you could say it's a set of computers that thinks and acts rationally. So it's modeling the best sort of human thought in theory. So let's move forward if we could. Bits and pieces of this, and these are things you may have heard as terms. There's machine learning, there's deep learning, there's neural networks. These are very key things in the whole AI realm, and they are basically ways of processing information that are different from the ways we have traditionally done it. So Mark was talking about using grip data and possibly pavement temperature data to adjust the application rate of salt from a truck automatically, okay? But that's not AI, that is smart technology, because what it's doing is saying, well, if A and B, then I do C. AI is a little different, and we'll get into how it's a little different. Mark alluded to needing to train the cameras, and the data to train all of this is going to be critical in developing AI. One of the exciting things about these friction devices is they actually vary we're getting all this information we can use to train things. So how do they actually do this? You take all this data, you input it to your AI system, and then it looks at it. And we have no clue, other than in very general terms, how it looks at it. But what it eventually comes out with is an output layer that considers all these factors and somehow, if the training is right, gives us some reality at the end of it. So if we go to the next one, Mark. In winter maintenance, to look at how we might look at this system as we have it on a plow truck, we use the inputs that we currently have. So it would be things like, what is the pavement temperature in the grip and the moisture levels and all of that. But we add in things like cycle time. Will it be 2 hours or 3 hours before I get back to this point? Oh, that might depend on traffic levels. So we can throw that in as well. And we'll have a forecast of the road condition going in there. The output, what comes out at the end is, hey, how much material should we apply? And what's the ideal mix of that being a solid or a liquid or some mix of the two? Should it be straight liquid? Should it be just lightly pre-wet solid? Where should it be? The goal, the outcome we hope to get from all of this is improved safety and mobility. Now, we can talk about this in terms of driver assist programs, in terms of automated vision and speech recognition and automated driving and automated spreading or dynamic spreading and a whole bunch of other things. It's not there yet, but the potential in that regard is quite large, I think. So what have we got next, Mark? I think we may be at the
that would
point.
be it.
Yes.
But I have
Yeah.
a question for you on that. Who is
Okay.
working on that? I mean, right now, when you look at what we're doing with dynamic spreading in those 3 examples we said, is trying to figure out, can we make it work, right? I mean, really,
Right.
that's what they're trying to do in those. But the AI part, which is going to be vital to this, where's
Yep.
that at? Who's working on that part,
At the
versus just trying to make them work right now?
At the moment, I think it's a concept. Let's put it that way.
Okay.
Okay. It's fun to talk about. It's most fun to talk about with a beverage in hand, because that helps stir the creative juices. But the potential is there, and I think we see that happening. But I don't want to also downplay the disruptive aspect of this. Just as we are now getting data from the roads on our trucks that we never got 10 years ago, so too we're getting data on all other aspects of the road system and various other bits and pieces of data. We are now, it sounds quite wonderful. We're awash in a sea of data. Okay, put us on a spin cycle or something. But we've all this data. The potential for using that is huge. I don't think we've even really begun to tap that potential. But anytime you have a pain point, and Allison knows that's one of my big phrases, pain points, we can use this new technology to potentially address it in due course. We're not there yet. As you say, Mark, we're at the point when we're still trying to use the data in a very specific and contained form to drive the output.
Well, I
This is
was-
talking about many
Yeah,
more
I was
outputs.
thinking to myself here, with all that we've done with liquids, I always looked at the forecast. Okay, what do we need for this storm? So even in a blending system, if
Yep.
I'm going to actually combine chemicals, that could really help me with decision making based on what, putting those inputs in and coming out with, this is the mix I'd use versus what I'm deciding personally.
Yep. No, I think things like that. And I think other things would be things like, okay, I'm putting down solid salt, but can I vary how much I pre-wet? As the temperature gets colder, maybe I don't need to put down more salt. I need to pre-wet at a heavier rate, perhaps. Sure. I don't think we have much, if any, knowledge on that yet. And we need to develop that, which is why it's exciting. And I get all excited, just in case you didn't notice.
So, Allison, we brought you a whole bunch of things that kind of hopefully work with what you're working with as well, but a little bit just of what's going on in the industry for you today. I hope you enjoy it.
I love it. Thank you so much. And I hope everyone saw questions are welcome right now. So you can type this into the chat, or I'll try to keep an eye on my email here for a minute. We brought you almost right up to the hour. So I do want to not go really over here because I know a lot of people are going to pop off. But yeah, I think, Will, if you summed it up well, explaining, it's like my one friend says the data lake, right? Like, let's do a deep dive into the data lake. And she's normally talking about, going out on her bicycle and having her heart rate monitor and looking at, how many miles and how many calories and how, like, where she went faster and slower. But it's like, yeah, we're talking not just road pavement temperature, but friction, and then this, information that we're getting maybe from these cameras about like what's visible. But you were saying, Mark, you showed us, some of those cameras are trying to understand what are the conditions, not just what we see at the surface. And like how I think already we know, operators have many more inputs beyond that, right? Where it is, not just the current weather, but the forecasted weather, what areas, uptown or of the highway have more or less traffic, and, are we heading into rush hour? And it's just like, let's add even more variables. Like, how does the human brain have the capacity, and they don't, right, to like interpret all that? So utilizing AI just makes sense. And I think it's so exciting to see, Mark, like those pictures you shared from Sweden and Norway, where the grader is just like, there's no more salt going down there. We're just, we're doing what needs to be done, and it's that focus on the mechanical. And I think also I think you had frost, ground cast, and temp cast, right? Are those, what do you say, like the three big in terms of the?
Yeah, there could be more, but those are the most common. Right now it's Vizsla and Frost, pretty much with those type of products at the moment. There probably are other ones out there already as well. So
Yeah, that's something I definitely want to kind of get more information on going forward. And I guess one thing that comes into my mind here is every time we're talking more technology, it's like, well, what's the cost, right? So I guess if you were, a part of a mid-sized agency that doesn't have an endless budget, I mean, not that anyone does, right? Like, which one of these technologies would you kind of have a recommendation, or would you say like might be more feasible?
that's a really great question, and I get that quite a bit, to be honest. And the answer is different for everybody, right? It really truly is. I know that's a terrible cop out. It sounds like it, but it's not. Personally, I would want to start with a weather station. And today you have options, even like leasing, right? Or subscription services. If you have nothing and you have very little budget, obviously those IoT sensors are there to really help you with that right now. They really are, because they're very low cost, but you're getting limited data with those, as you would, but we know agencies, Wolf and I talk about this all the time. The only thing they got is something they can hang out the window and shoot the ground, right? I mean, if that's all you've got, then any kind of a sensor that's out there 24/7 will make a huge difference, because you can see trends, you can see what's changing, you can look at those kinds of things. Obviously, a full-blown weather station of any kind gives you both atmospheric data and road data, and it's out there all the time. It's always working. You put something on a truck, the mobile data is fantastic, but it's sitting in your garage when it's not on the road. So, those things, everything has a trade-off in what's the most important. So, like anything, I've always said, any technology, we worry about return on investment, we worry about cost. Any technology that makes you more efficient was worth the money, period.
Yeah.
Right.
Yeah.
And if it helps you environmentally, how much better is that? Right. So making proper decisions. I mean, technology is great, but training is equally as important. So
do we actually use it, right?
Yeah.
Not being off the phone of like, how do I do this thing? My mom's always like, I didn't mean to do that. Did I call you?
Yep.
You called me. I'm like, no, Mom, you called me. But if you talk, it's okay. So no, this was great, you guys. Thank you so much. Just in terms of time, I'm gonna cut us off here. If other questions come through, I will send them your way. I'll probably take like a couple little clips of this and try to put them up on YouTube. And Wilf, I can, tag you guys. Mark, I can tag Vizsla too.
Sure.
And,
Perfect. Sure.
Yeah, and this will be archived, so we can share it, continue to share it out. And thank you so much for making a little Saltwise specific presentation and Wisconsin, shout outs there. We are doing incredible things in this state, and there are so many other people to learn from, right? So I think that's the beauty of this, is just keeping those conversations going. So yeah, thank you both.
Well, thanks for having us.
Thank you. It's great to share all this stuff, and as I suspect you noticed, Allison, we have a certain degree of enthusiasm about this.
Yeah. A thank you to everybody that joined us today and what you do. We really appreciate what you do. It means everything that you're out there taking care of our roads. So thank you. Have a safe winter.
Yes. Amen to that. Yep.
Take care.